It is amazing that 27 years into democracy, South Africa still reflects the legacies of her past, smeared by deep inequality. Scores of South Africans remain confined to poverty-stricken informal settlements dotted around economic hubs. There is little to no access to clean water, waste management facilities, ablution facilities, sanitation, living below the poverty line, in close proximity to very affluent communities. The stark differences are hard to unsee, but no community is an island. The effects of these living conditions are typically felt across the board. Often these manifest as environmental pollution. Sources of contamination know no bounds. They reach receptors far beyond where the eye can see. The stable river catchment is a great microcosm of this reality, an illustration that nature somehow connects the dots. The stable river catchment is nested in the Cape Winelands, a home to almost 3,000 dollar millionaires. The river, flowing from the Highlands Mountains, first goes through Limburg. This is an informal settlement in the uppermost reaches of the catchment. There is only one formally paved road. 6 tap stands supply potable water. Here, almost 6,000 people are struggling to live in less than 2,000 informal dwellings. Located on the mountainside, rainwater is often difficult to control due to poor drainage and the lack of flooding channels. Grey water streams run freely throughout Limburg, increasing the risk to human health from this dam contact. As expected, grey water, domestic waste, pharmaceuticals, fecal sludge, and so much more ends up in the water. Further down, the river meanders through a low-income built-up area in Grunedal. This area is comprised of low-cost government housing with paved roads running in between the houses. However, cleaning agents, plastics, pharmaceuticals still make their way into the river. In its last leg, downstream, it goes through agricultural fields. Fertilizers, other chemicals run off into the river. Now, what are the implications of this polluted water to its receptor, the Franschoek River? What does it mean for farmers who directly abstract this water for irrigation in commercial farms? For households that use the abstracted water for domestic purposes and for drinking?
And the farmers here, who are all export farmers mostly, and further downstream, complained in 2007 that the water quality from this wastewater treatment plant over here was causing such difficulty for their exports, and the European Union even came along as a commission to understand what the quality of the water was and warned the farmers at the time that if you don't start improving that water quality, we will take our export markets from Chile in South America, and we'll leave you guys with your 3 billion rand export and your 3,000 and more workers in the lurch.
The Water Hub is a learning site of the Future Water Institute at the University of Cape Town. It is set on a decommissioned wastewater treatment plant, now being readapted for our research purposes. At the site, we are learning how to treat contaminated water from upstream areas through nature-based systems. This is an urban living lab where we are learning how to work with nature rather than against it. The work at the Water Hub began with the challenge of treating water from the polluted river. It is extremely high in nutrients, and this got us thinking, what if we could use that water by reducing the concentration of the pollutants? The work began by converting the old drying beds that were once used for wastewater treatment, and we turned these into large biofiltration cells. We filled these large beds with different sources of natural media, large and small stones, pitch pips, and then we grew plants on top of some of these cells, much like a constructed wetland. Polluted water was then pumped from the river into each of the cells. There our journey began. The challenge is to improve water quality by managing the amount of time that water stays in each of the cells and controlling the speed of the flow. We are achieving some exciting means of monitoring the flow of water using digital sensors and loggers that send data via the internet to our servers. It is helping us understand the rhythms and patterns in water quality and flow. Before we use the water, it passes from the biofilters into a series of irrigation cells containing a common duckweed. This helps to further reduce potassium and salt concentration as a final stage. We have been surprised with the results. After 2 years, we are now seeing some exciting results. The results show that the inlet pollutant concentrations are substantially reduced, with the outlet concentrations falling within the acceptable concentration range for irrigation purposes in South Africa. For an example, ammonia is reduced between 70 and 90%. It is removed by the bacteria inside the cell. Nearly 100% of E. coli is removed from the water. Researchers at the site are now using nature-based processes to clean this water, and we are reusing this water to irrigate vegetables and to support a small aquaponic systems containing a small fish population. About 50,000 to 100 liters of water is treated each week. Doesn't seem much, but there is more than enough water to support a large garden of nearly 1 hectare of land. Our treated water is meeting the South African irrigation standards, and the vegetables are compliant with food safety standards. Each time we harvest, samples of the crops are analyzed by an independent laboratory. Included in these are samples of vegetables from other local supermarkets. The results are astounding. Our produce often has results better than what is found in the local supermarkets. Although these results are promising, we continue to advance our nature-based systems. We are pacing ourselves. For an example, we are now using select fish species at the site as biomarkers to understand the risk of pharmaceutical waste in river streams. We have shared some of the produce with the community. We are integrating the community in an organic way through opportunities of employment, training, and an open gaze policy. Our work is not done. We are continually brainstorming other forms of non-invasive means of integrating all stakeholders. The limitation of basic services upstream in the catchment is unlikely to change, at least not overnight. Our hope is that through meaningful interactions at the Water Hub, various stakeholders can gain a fuller understanding of the extent of the pollution and the associated health risks. Only then can people truly become change agents, changing how water is viewed in the upper reaches of the catchment, thereby treated differently.